100% daily vitamin C. Really? How do they know?
Every day, we drink beverages claiming to be rich in vitamin C. But have you ever wondered how they actually measure that? So guys, in this video, we're going to explore how volumetry analysis works and how it's applied to determine the amount of vitamin C in orange juice using theory, methods, and a real calculation example.
What is volumetry analysis? Volumetry analysis is a method of quantitative chemical analysis that relies on titration to determine the amount of substance in a solution. This is done by measuring the volume of a region required to completely react with the analyte.
Volumetry analysis is a quantitative chemical analysis method that uses titration to determine the amount of substance in a solution. This is done by measuring the volume of a region, which is a solution of known as concentration, needed to completely react with the analyte or the substance we are analyzing. Titration is a technique used in a quantitative chemical analysis. In this case, we use type called redox titration, which involves both oxidation and reduction reaction. The purpose is to determine the concentration of substance, such as vitamin C in fruit juice. In this titration, ascorbic acid or vitamin C act as the reducing agent, while iodine is the oxidizing agent. The reaction is 6 carbon, 8 hydrogen, 6 oxygen plus iodine, make 6 carbon, 6 hydrogen, 6 oxygen, 2 hydroiodine. A starch indicator is used. The endpoint is reached when there are blue-black color change, which means excess iodine in presence and react with starch. This color change tells us the reaction is complete, and from this we can calculate the amount of vitamin C.
Let me show you the step of titration. First, we begin by transferring a known volume of ascorbic acid sample into a clean conical flask using 10 ml pipette. This sample contains the vitamin C we want to measure. Next, we fill the burette with a standardized iodine solution. Iodine will react with the ascorbic acid during the titration. Then, we add a few drops of starch solution into the conical flask. This acts as an indicator and helps us detect the endpoint of titration. Now, titrate the ascorbic acid solution by slowly adding iodine from the burette. While swirling the flask continuously, the iodine reacts with the vitamin C. When all the vitamin C is used up, the next drop of iodine reacts with starch, forming a blue-black color. This marks the endpoint. Look at the example of result from the titration experiment. In this experiment, we titrate 10 ml of juice with iodine solution to determine the vitamin C content. The molarity of iodine used was 0.005 molar. From the titration data table, we have 3 trials and the volume of iodine used was 18.9, 18.7 and 18.8 milliliter. By averaging these values, we get 18.8 milliliter or 0.0188 liter of iodine solution used. Since the reaction between iodine and vitamin C follows a 1:1 mole ratio, we can use this data to calculate the amount of vitamin C in the juice. Now, let's go through the step-by-step calculation. First, we calculate the moles of iodine used using the formula mole equals M times V. So, 0.005 molar times 0.0188 liter give us 9.4 times to 10 power of negative 5 moles. Because the mole ratio is 1:1, the moles of vitamin C is also 9.4 times to 10 the power of negative 5 moles.
To find the concentration, we divide the moles of vitamin C by the volume of juice used, which is 0.01 liters. That gives us 9.4 times to 10 to the power of negative 3 molar. Finally, we convert this to milligram per 100 milliliter. We multiply the moles by the molar mass of vitamin C, which is 176.12, giving us 16.56 mg in 10 milliliters. So in 100 milliliter, the vitamin C content is 165.6 milligram per 100 milliliter. This shows that the juice sample is rich in vitamin C.
From your breakfast juice to health supplements, volumetry analysis plays a crucial role in ensuring nutritional content is accurate. It's a perfect example of how chemistry safeguards our health every single day. So next time you sip your vitamin C drink, thank analytical chemistry.